This is about programming language translators assignment done under kannadasan.R. These are our group members, and now shortly we are going for the lecture. In this video we will discuss about LA11 parser. Here we will check are there any conflicting entries. So consider the given grammar, and here we can see that let the grammar which can be written using augmented grammar s-use.s. Here we can see at the top. From this we will construct canonical set of items L1. Here we can see I0 gives s-gives dot s comma dollar. These are the initial productions. So for the first production s-gives dot s, we have the rule s-gives dot s. The corresponding rule will be a gives alpha dot x beta for the following conditions. Here we can see those conditions, and as after dot s is coming, the closure rules on s can be applied as follows. So for getting I1, here we need I0 and s, so that we can move one dot ahead here. For getting I2, we should have I0 and I. Here we are moving one dot ahead. Similarly for I3, we can see here, we can notice it here. Similarly for I4, it is obtained from I2 and C, and we are moving one dot ahead until we get dollar. Similarly we move like this for I5 and for also I6. Here we can see it's obtained from I4 and T, and I7 it's obtained from I6 and S. So we are moving one dot ahead, and similarly we'll get the remaining states from I8, I9 to I16. Now we can see here we can merge the states having common first component but with different second component. Here we can notice that. Hence by merging 2 and 8 we get I28. These are the some common states. And by merging 3 and 9 we get I39. By merging 4 and 11 we get I411. By merging 6 and 13 we can get I613. By merging 7 and 14 we get I74. Here we can see. Now by merging 10 and 15 we get I1015, and by merging 12 and 16 we get I1216, and we got the states which have been merged. And now for the obtained canonical set of items we are going to construct a parsing table. So here we can see the states 0, 1, 2, 8, 3, 9, 4, 11, 5, 6, 1, 3, 7, 1, 4, 10, 15, 12, 16. An action table. We have got terminals I, B, A, T, E, dollar, and we have go to, which contain S and C, from which we have been arrived so far. And based on the terminals and states we are going to fill. For state 0 and terminal I we have S28, which have been merged so far. So we got the states which have been merged here, that we can notice. And the important thing here is we got dollar at the end, we got accepted, that is for state 1, and dollar we got accepted. And from this we can justify one thing: there are no any conflicting entries. So this is about LA11 parser. And next we are going for the activation record. And the important thing here is we have to remember that data storage for subprograms is an activation record. Here we can see the diagram activation record for P, which contains L value of X, and here we can see an expression x equal to y plus z, which tells about locating activation record containing y, and get L value of Y from fixed location in activation record. And also we can repeat process for Z and then X. And regarding scope rules, the scope of a variable are the set of statements where variable may be accessed in a program. We have static scope, dynamic scope, static nested scope, and the following rest. And now we can see in this diagram Q and T are the declarations, like we have seen here. Q and T are declarations of procedure within P. So scope of names Q and T is same as scope of declaration of A, small variable A. R and S are declarations of procedures in Q. Here we can notice this. And U is declaration of procedure in T. Here we have U, which is a declaration of T. This we can notice from these lines which have been here so far. From this we can notice that. And here storage managed by adding activation records when procedure invoked on a stack. Now this is the typical activation record structure. Here we have activation record for one procedure and memory organization during execution. Here we can notice we have static storage, stack pointer, and end of stack block which contains heap. Here we have activation record storage. So far we have been discussing that. This is the typical activation record structure. We have some of the parameters, formal parameters, local variables, temporaries for expression evaluation in the activation record for one procedure. In the memory organization during execution, we have some program code which we have been so far discussing, and heap, and also activation record structure. And we have an example of activation record structure which contains static link, dynamic link, data, SL, DL, data, and so on. That loop continues. We have those declarations P, Q, S, and calls S, R, Q. From this we can understand. Next we have activation record example 1, which gives about C equal to B plus A, where here C is local, A and B are global variables. Suppose assume AR is current activation record pointer and B is one level back. So we can get R value of B from fixed offset L value. A is two levels back. And add R value of A from fixed offset L value. C is local here. We can notice from this. We store sum of B plus A into L value of C. This is clear cut example for activation record stack. And example 2 we have A equal to B, where clearly we can notice that B is local and A is global. And now in the first step we get R value from local activation record, and in the second step store R value of B into L value of A. And this is some of the typical examples of activation record stack. And here the important thing is compilers know static nature. So it can generate the number of static link chain it has to access in order to access the correct activation record containing the data object. This is compile time, not a runtime calculation. This is what we infer from this. And so far in this video we have been discussing about LA11 parser and activation record stack. And thank you for watching this video.